Assalamu alaikum everyone. My name is Nafis Ahmed Nahin and my ID is 22108025 and my group members are Prosenjit Barua, MD Janatul Islam and Al Hasib Rahman. Today we are talking about air quality monitoring system using Note MCU and Blink. Here our acknowledgement. We would like to express our gratitude to Khairul sir and Rakib sir for their valuable guidance, constant support and insightful suggestion throughout the development of our air quality monitoring system. Their mentorship played a crucial role to the successful completion of the project. Here, IoT-based real-time air quality monitoring systems, some developing of our real-time air quality monitoring system, integrating of the Blink IoT platforms. Here we use MQ series gas sensors. They are MQ135, MQ9, and MQ2. Here we incorporation of DH11 sensor for environmental condition. The DHT11 sensor measure both temperature and humidity. Here we display of the data a 16 into 2 display. Here we see the low cost and scalable IoT solution. Here our design and implementation of an IoT based air quality monitoring system. Here we see health and of air pollution. Second, importance of real-time monitoring. Third, advantage of IoT and embedded systems. Fourth, system design overview. And fifth, integration of multiple sensors. Here we see some essential equipments for air quality monitoring systems. They are Node MCU ESP8266. This is a microcontroller with Wi-Fi capability. Second, our sensor MQ135 sensor that detects toxic gas detection capabilities. Third, MQ9 sensor, it detects methane and other some gases. DHT11 sensor measures temperature and humidity. And fourth, Blink IoT app. This ensure mobile application for real-time monitoring. Now my friend Jitu continue the next part.
Here my name is Prosenjit Boro. My ID is 22108001. Here we see the circuit diagram. First of all, we see that we use three gas sensor MQ2, MQ9 and MQ135. There are three pins in gas sensor. The GND pin is connected to the ground of node MCU 8266. The BCC point is connected to the 3 board of node MCU, and the output, or mainly the sensor output, is connected in the multiplexer is CD4051, and their selection pins are connected to the node MCU D5, D6, D7 pin. This is the other digital pin, and we see that there is a DHT sensor which measure both temperature and humidity. It has a chip pin also. The VDD pin is mainly measured. Sorry, it's mainly measure not. It is connected to the voltage of node MCU 3-volt pin, and the ground is connected to the node MCU ground point, and the data pin is a digital pin. It is connected to the node MCU D4 point, and we see that we use a LCD display which is 16 into 2, and we use I2C protocol. That's why there is a HD and SCL pin which is connected to node MCU D2 and D1 pin, which is also a digital pin, and the voltage and ground is also connected to the node MCU digital pin. And we explained our working principle in this slide. The node MCU, which mainly control the entire system, reads analog values from the gas sensor and digital values and send data to the I2C LCD and Blink mobile apps. And gas sensors MQ2, MQ9, and MQ135, which is mainly connected through the 405, and what I say also. And the MQ2 mainly measures smoke, LPG, and methane. MQ9 is carbon monoxide for carbon dioxide, and MQ135 is air quality, is mainly alcohol, benzene, and ammonia gas. CD405 I say also, this is a multiplexer. These have two CX1 pin and one analog pin. And DHT11 sensor is mainly temperature and humidity sensor, and the display, which is also used for see the data, which is also shown on Blink IoT. And this is our PCB layout. We use ferric chloride and for the PCB making, and we use mainly PCB software for making this PCB design. And this is the PCB wiring diagram. We see the component connected to the MCU and description. MQ sensors are connected to through the CD4051 Y0 to Y2, and this is our analog and description analog output of the sensor. And CD4051X is the analog sensor which is connected through the A0 point of node MCU. CD4051 control pins ABC is connected to through the digital pin node MCU D5, D6, D7. DHT11 is connected to node MCU, digital pin D3, I2C LCD SDA pin is connected to node MCU D2 pin, and I2C LCD SDA pin is connected also D1 pin in the node MCU, and BCC and ground is connected also node MCU 3.3 board and ground point. And from the next slide, continue my next fellow 2210022 Alasif Rahman. Continue from this. Mr. Alasif Rahman.
Assalamu alaikum. My ID is 221023 and my name is MD Alasif Rahman. Now I'm talking about the essential software and tools for air quality monitoring system. In our project, we use Arduino IDE and Node MCU programming. And the Arduino IDE is a crucial software used to program the Node MCU, enable it to process air quality data effectively. Then we use Blank library for mobile integration. The Blank library allows for wireless connectivity and integration, and we use Portage Design Suite for circuit simulation. Portage Design Suite is used for simulating circuit functionality, ensuring that the air quality monitoring system operates as intended before physical development. Serial monitoring for real-time debugging. The serial monitor is an essential tool for debugging and calibrating the system in real time, allowing for immediate adjustment and troubleshooting. Now, the methodology of air quality monitoring system. Here we use sensor calibration, like essential starting point for accurate reading. The second is multiplexing control, efficient channel management for sensor. Third is data equations, transforming analog signal into visual data. Fourth is environmental sensing, monitoring condition for accurate readings. Fifth is data display, real-time information accessibility. Six is cloud sync, ensuring up-to-date inform is available. Thank you. Now my another team member, MD Russell, will continue the next part.
Assalamu alaikum. My name is Jannatul Islam. My ID is 2210002. Analysis of air quality sensor result. MQ135 sensor findings significant CQ levels in properly ventilated areas. The MQ135 sensor effectively detect spikes in carbon dioxide and concentrations, indicating poor air flow and ventilation, crucial for maintaining indoor air quality. MQ2 sensor responds high sensitivity to smoke and LPG leaks. The MQ2 sensor showcased sharp reaction to smoke for fires and liquefied petroleum gas leakage, highlighting its effectiveness is safely application. MQ9 detector methane and concentration near gas storage. The MQ9 sensor
Here we see our video project, my dimension of our project. We see that when we burn something, M2 sensor is detecting this and the analog value is increasing, and we see the data on Blink IoT app. We also see this way. We also demonstrate also. Here we see that in mobile app, we see that M2 sensor level is increasing.